Hey everybody, so in this video we're going to talk about using some of these other trigonometric formulas that you can see on the screen right now. So in this video we're going to focus on the sum and difference formulas, the ones that you see here in the top left. And we're going to talk about one particular type of example that you can do using these formulas. Okay. And like I said in class, in the other videos, we'll talk about a couple of different types of examples. So let's go ahead and get started on the example here. So what we want to do is we want to evaluate a trig function at one of the angles that isn't a special angle. Okay, so we want to find the exact value of sine of 5 pi over 12. And we know that 5 pi over 12 is not one of the quadrantal angles, and it's also not a special angle, right? So it's not something that's going to have a reference angle of 30, 60, 90, right? And so or 45 degrees, right? We know that those things look like pi over 3, pi over 6, pi over 4, pi over 2, and then whole multiples of pi, like 2 pi, 5 pi, etc. Right? So the first thing we want to do is write this 5 pi as either a sum of difference, okay, of some special angles, okay? So we want this to be either the sum of two special angles or the difference of two special angles. So if we're thinking about 5 as a sum, we have a couple of choices. We could go with 1 pi over 12 plus 4 pi over 12. Okay, now 4 pi over 12 is a special angle, right? Because this reduces to pi over 3, okay, which is one of our special angles, but pi over 12 isn't. So this isn't really a good idea for us to split it up this way. Okay, so instead, let's try our next choice, which is just 2 and 3. Okay, so if we go with 2 pi over 12 plus 3 pi over 12, right? And then we look at what this reduces to. This is going to reduce to pi over 6 plus pi over 4. And those are both special angles. So this is a good way to split up this angle. Okay, so what I have when I look at sine of 5 pi over 12, okay, is I can know that I can split this up like sine of pi over 6 plus pi over 4. Okay. Now, the most important thing about these sum and difference formulas is that you know you can't just split this up like sine of pi over 6 plus sine of pi over 4. None of the trig functions work that way. So what I need to do is look at my identities, right? And I can see here I have for sine, it's a sum, okay? So my first one was, I think pi over 3, let's double check. Pi over 6 and pi over 4. So when I look at, again, these special angles, this is going to be pi over 6 and this one is going to be pi over 4, okay? So I'm just going to use this exact formula with alpha being pi over 6 and beta being pi over 4, okay? So this is going to be sine of pi over 6 times cosine of pi over 4, okay, plus cosine of pi over 6 times sine of pi over 4. Okay, so it's sine of the first angle, cosine of the second one, and then cosine of the first one, sine of the second one. So let me just double check that against our formula here. Sine first, cosine second, cosine first, sine second. Okay, so we're really just evaluating that formula with these angles. Okay, so now I'm going to go ahead and draw these two angles that I'm talking about, right? My pi over 6 angle. Okay, so this is going to be 1 root 3 and 2, okay? And then if I look at pi over 4, right, this is the 45, 45, 90 triangle, so this is going to be 1, 1, and root 2, okay? So I'm going to use those two reference triangles to evaluate this. So sine of pi over 6 is going to be the opposite side 1 over the hypotenuse 2. Okay. Then cosine of pi over 4 is going to be the adjacent side 1 over the hypotenuse root 2. Okay. Cosine of pi over 6 is going to be the adjacent side root 3 over the hypotenuse 2. And sine of pi over 4 is going to be the opposite side 1 over the hypotenuse root 2. Okay, so I'm going to go ahead and multiply these together. So here I'm going to get 1 over 2 root 2, okay? And in my second term, I'm going to get root 3 over 2 root 2. These already have common denominators, so I'm just going to go ahead and add them together. So I'll get 1 plus root 3 over 2 root 2, okay? I don't want you to feel compelled to simplify this any more than that. You don't need to rationalize the denominator in particular, okay? And this is a perfectly good way to leave this answer, okay? All right. So I actually want to do this same example again, but instead of writing 5 pi over 12 as a sum, I'm actually going to write it as a difference. So let's go ahead and start over. Okay. So we're doing the exact same question, and I just want to look at how we could have done this differently using the difference formula instead of the sum formula. Okay. Now I want to think about this as the difference, right, or subtracting two angles that are both going to reduce, right? So I don't want to pick like 7 pi over 12 because that's not going to reduce at all. So I'm going to try 8 pi over 12. Okay. And, oh, of course it's subtraction. So minus 3 pi over 12. Okay. Now you can see that this will subtract to 5, right? 8 minus 3 is going to give us 5. But is this going to reduce to something that is a special angle? So here when you reduce, you're going to get 2 pi over 3, right? So these pi over 3 type angles are special angles. And here this is going to reduce to pi over 4. And we know that that's also a special angle. So this should work for us. Okay? So again, I have that I can break down 5 pi over 12, and I can split it up like a difference this time. So it's going to be 2 pi over 3. Oops. Minus pi over 4. Okay. And now, when I look at my my trig identities, I want to look at the difference formula for sine. So here's my sine, and I am looking at the difference formula, okay? So you can see this is exactly the same as the sum formula, except for the minus sign here where the sum formula had a plus, okay? Now, you don't need to memorize these trig formulas, any of the ones on this sheet. What you do need to remember is that there are formulas for the sum and difference of all of the trig functions, and that you can't just split them up like sine of alpha plus sine of beta, right? That's the most important thing to remember, that it doesn't split up like that, okay? All right, so let's go ahead and split this up using the formula. So we're going to have sine of 2 pi over 3 times cosine of pi over 4. Remember, the minus sign is telling us to use the difference formula, so we're just using the two angles themselves and not the minus, okay? And then we'll have minus cosine of 2 pi over 3, okay, times sine of pi over 4. Okay, so again, when you check the original formula, right, it's just going to be sine alpha cosine beta minus cosine alpha sine beta, okay? So that's exactly what we have here. Okay, so let's go ahead and look at what happens when we evaluate these two things. So we're going to look at 2 pi over 3, okay? Now 2 pi over 3 is going to be here, okay, with a reference angle of pi over 3, right? Our reference angle is going to be pi over 3. So that means that this is going to be the longer side, the root 3 side. This is going to be the 1 side, but it's going to be -1 because it's facing to the left. This is going to be the hypotenuse 2. And then pi over 4 is just the basic 45, 45, 90 triangle, right? So we'll have 1, 1, and root 2. Okay. So when we go to evaluate these, right, I'm going to have sine of 2 pi over 3, so that's going to be root 3 over the hypotenuse 2, okay, and then cosine of pi over 4 is going to be the adjacent side 1 over the hypotenuse root 2 minus, okay, cosine of 2 pi over 3 is going to be the adjacent side -1 over the hypotenuse 2, right? And then sine of pi over 4 is going to be my opposite side 1 over my hypotenuse root 2. Okay, so this is going to give me root 3 over 2 root 2. Okay, and here I have negative times a negative, so positive 1 over 2 root 2. Okay, so you can see that we get exactly the same answer that we got before, right? The terms are reordered, right? Because before we had 1 plus root 3, and now we have root 3 plus 1. But either method will give us exactly the same answer, and they're both correct methods, okay? So I hope that kind of explains how you can use the sum and difference formula to evaluate angles that can be written as the sum and difference of our more basic angles, okay? And I will see you guys in class.